So before I get started, a word about the title. As you can see, I made some change here. So when I proposed this presentation, I thought that edge native would be a cool way of saying what I want to say. But in the meantime, I learned that edge means many different things to many people. And it means something confusingly different to most people than what I want to say. So the whole principle, the whole working title has been changed, and now it's called Local First Cooperation. This is, of course, a lot less catchy, but it is way more precise. So I like it much better. Now, this presentation is about how we humans work together using computers and how we will work together with computers in the future. As one extremely basic example of that, let's consider that we're working together on some shared document. This might be Google Doc that I'm sharing with my team and then collaboratively editing. It might also be something a lot simpler, like sharing the state of some light switch in my home between my phone and the electric switchboard. It might also be the process of a set of autonomous vehicles deciding who will cross a certain crossing first. Today, this all works via the cloud. So we have a copy, a representation of the document that we're working on some phone, for example, and on my computer. But then each of these devices needs to constantly talk to the cloud, because that is where the magic happens. The changes that I do are sent up to the cloud and organized there, canonicalized, merged, and so on, and then sent down back so that others can see what I have done. This working principle is true for many. I just named a few examples with Notion here as well. This is also basically how IoT works. IoT is supposed to be an Internet of Things, but I think it is currently, the way we're doing it, more like a bunch of things that are connected to the cloud, because everything just collects data, perhaps pre-processes, and then sends to the cloud where the magic happens, and then sometimes commands are sent back to the devices to change something in the real world. So, as I can see, there are two main problems with this. The first problem is that while working together on some shared data set or document, all the devices that are participating in this need to be constantly connected to the internet. They need to be connected to the cloud so that they can exchange these change sets and synchronize their state of the document. We know that the cloud is fairly reliable. We can build applications in the cloud native applications that are pretty much reliable, as Jonas talked about. But we also know that connectivity of mobile phones, for example, or even my DSL connection, I hope that it will hold for this presentation, they are not reliable. This is a problem that can be fixed in principle, but I do not think that it will be fixed in practice, because it would be just too much effort. We would have to spend lots of resources going from 97% availability, like for a common DSL connection, to 99.999 or whatever we want. So the second problem that I have on this slide is about ownership. I give my data to someone else. So if I use some cool new tool for collaborating on some whiteboard, then my data are actually owned by some startup on the other side of the planet. If that startup goes bankrupt, then my data are gone. I do not have them, I'm not the owner, they are not really my data, I just borrow them for editing. This ties into the second part of that problem, namely that the interaction with these data is also mediated via the third party, like that startup. So I can usually export data in some formats, but these are static interchange formats like PDF or HTML or Markdown, but I cannot really download the data in such a way that I can use them for collaborative editing, because that part is only provided via the cloud service. So I'm lacking ownership and agency, and I think this problem is fundamentally unfixable. We could only fix it if everybody had their very own cloud, but then it wouldn't be a cloud anymore. So it is the nature of the cloud that kind of contradicts what I want to express here. There are more problems than these two, some of them more technical in nature, for example, regarding latency and bandwidth consumption. This is currently being countered by moving the magic closer to the end devices. So by pushing things from one data center where it used to be into multiple data centers, like, for example, in my home country or even in my hometown. This way, the distance between where I use the document and where the magic happens can be reduced. But this doesn't fix any of the two fundamental problems that I noticed. So this going to the edge is very useful, even though it doesn't fix it. But it's one of the ways in which we are currently doing something that's called decentralization. We used to have something in one place only, and then we decentralize it. So we take that same function, like editing that document, and make it available in many more places. It doesn't have a clear center anymore. Physically, it is all around the globe. We can make it ubiquitous even, but in the end, the structure stays the same. The communication structure stays the same. The clients still do not talk to each other, but talk to some third party. So it is still central in essence. The same is true of blockchains. Blockchains are also viewed as a way of decentralizing the central function of managing a currency, for example. But still, there is this central piece, which is the longest chain of blocks, and there is just one of them. So it remains central in a certain sense. I think this word and this way of thinking and going about it is just the wrong way of doing it. I think we need to completely look at this problem from the other side. We need to switch perspective, switch focus. Enter local first. Local first is a term that has been coined by the people at Ink and Switch, which is a research lab. You can search for it, you will easily find it, and I highly recommend you to read that paper, which explains in much more detail what I just said. Local first, and we also want cooperation. So I put these two words together to describe that we start focusing on the individual, on the local parts, on where we want to interact with computers or via computers, like in my home. And then the important part here is that the magic is not concentrated in one place. The magic is in the middle of it all. It is all the interactions that happen. It doesn't have one clear place. So it's not decentralized, it is local to begin with. How does this all tie into Reactive? You've seen this graph if you looked at the manifesto, responsive, elastic, resilient, message-driven. To quote from the first principle, from the first tenet, the system responds in a timely manner, if at all possible. This is the most important thing. Jonas also said it in the keynote. This is the desire from which many other points are derived. The reactive principles are derived from that ultimately. So this is what we really want. We want to have a system that stays useful to us, that we can use to perform useful tasks. We want computers to serve us and not the other way around. How can we do this? How do we start doing that? So we're starting looking at one single device, and let's see where that leads us. So one of the things, it just came to mind first, is if I have a Google Doc, for example, on my laptop and on my tablet, they cannot sync directly, but I really want that. So as soon as I have two devices that are close to each other, that have some sort of network communication going between them, Bluetooth, Wi-Fi, I don't care, then it should work. Local communication is all that is needed to make the magic work. This is a very important change in design, a shift in the perspective of how to look at things. There is no central thing, there is no third party involved, nothing. We talk about local, really peer-to-peer communication here. That's the first principle that I think is really key. Local communication does not mean that our range is limited. It does not mean that we only can talk in shouting distance. For example, in the lower left, I might do some edits and then they sync with my tablet. And then I could take this tablet, put it in a car, drive to a different city where there is another computer. Notice how this process has covered both space and time. And I have brought the information elsewhere. And then this computer might sync with some other place. And it might even sync with a virtual place, somewhere in the cloud, for example. It might also sync with one of my friends, and it doesn't really matter where that friend really is. Locality in that sense, as I mean it, is mostly physical, but not always. It just means that there are people or things interacting that logically belong together and that should be able to interact. Now, with hierarchical behaviors, with transporting across multiple hops, we can make this span larger distances in space and time, as I said. Second part, Jonas spoke about that from a cloud perspective a lot, is autonomy. Autonomy in cloud native is needed to really get a clear vision on the boundaries of each component. You need to spend some effort to make yourself aware of those boundaries, so that you don't violate them and so on. If you look from a local first perspective, it is natural, because if I just take my tablet, I expect the app on it to work. I want to see what's going on, what went on with this document. I want to be able to use the app to its full extent. I want to see, for example, the editing history so that I can make further improvements. The system needs to stay maximally useful at all times. And everything that was on the tablet, that was known to the tablet, should be at my disposal. Even if, as here, there is no other communication peer. So I'm not actually sharing the document at this very moment. I'm not sharing my changes at this very moment, but I want to use the device. And this is a very fundamental cornerstone. If you look at how you use apps on your phone or on your tablet, you will see that most of them don't really allow that. Some are better than others, and things are getting better. But this autonomy is still something that you really need to carefully look for. Now, once we have built these pieces that are individually useful, each by itself, the main purpose of this whole endeavor was to work together. So we want to share work. As one example, I might want to share this document between my laptop and my tablet. And it should just work no matter where I am and walk between them and so on. Or I might type in one location and then a friend of mine might type in a different location. So we need these protocols. Again, Jonas mentioned that as well, that allow us to take the changes that I get generated on the left and the right side, ship them to the places where they need to be, and then reconcile them. Create a view onto the document on either side of this collaboration and make it work such that people can really work together. CRDTs are one really useful tool that appeared a bit more than 10 years ago. And there are other examples of tools that can be used. If you look at the local first paper, one of the authors is Martin Kleppmann. He is the author of the auto-merge CRDT, which is basically a JSON document that is synchronized automatically across all the devices, which can obviously be used to model some very cool UIs. Then the next point, Jonas talked about this as well. is if I have my view on this document on, let's say, my tablet, I cannot really know whether at that moment in time, someone else is typing to a different copy of it on a different device. It might just be a matter of 10 milliseconds for the changes to reach me, or it might take longer because communication currently doesn't work. We don't really know. We only know that we have some version that incorporates like some knowledge up to some point in the past from all the other collaborators that also contributed to this document. We need to still allow the end user, which might be a human or an algorithm, to take decisions based on this incomplete knowledge. We need to acknowledge that we cannot know everything. We need to make guesses, and we need to apologize. As Jonas, I can also only recommend reading Pat Helland's papers on this. The last of the most important principles that I'm presenting here is that you need to embrace that the network is really dynamic. We are talking about physical things mostly. We are talking about machine gateways, we're talking about laptops, tablets, phones. We are talking about things that you can really touch, take, move, put into a different context. This means that the way in which the cooperation between these devices is used, which documents are worked on and by whom, changes all the time. So we might have the situation here where there was some cooperation between these three devices, and we need to be ready at any time that one of them leaves. And this must be fine. This must be totally okay. The other two can then continue as if nothing else happened. It's just that the third one doesn't contribute any changes anymore. Or someone new could come and join. So they need to synchronize up and then also can start contributing changes. In addition to these 5 core principles, there are other very helpful points. For example, when you communicate with someone, the most useful thing that you can communicate is a fact. If you communicate guesses, then the recipient needs to know what you guessed, what your assumptions were, what you might have known at that time. So in order to understand a guess, you need to know a lot of what happened at the source. If you, on the other hand, communicate facts, then they can be taken at face value. And the recipient can just insert it into its own catalog of knowledge and derive new knowledge, make new decisions based on that, and so on. So facts are much easier to work with than guesses. The second, Jonas also talked about that a lot. We cannot expect to have a consistent worldview. We cannot always run a consensus algorithm to determine whether we can go forward with editing that shared document. Sometimes it's required though. So there are examples like you want to figure out which vehicle crosses a crossing first. In my context, that often happens in factories. You might want to distribute tasks. So if you want to supply new input materials to some machine, you need to make sure that only one of them takes them. If it's an expensive thing, then you might want to make sure that it really happens only once, then you need consensus. But the point is that you need to make sure that you really need consensus before employing it. And you should employ it only for the scope that really needs it and nowhere else. The third one is also very obvious if you think about autonomy. But it perhaps should be mentioned here that if you write apps in the way as I described until now, so you have these apps that run on very different devices and that work together in ways that you couldn't really foresee because everything is so dynamic, or people might deploy different versions and so on at different times, you need to spend a lot more time writing down the data formats and the protocols. Because if you don't do that, then the collaboration will not work. the devices, the apps will not understand each other. It will be useless. So in order to make it maximally useful, you need to settle on some protocols, get together in relevant groups and define what kind of data you want to exchange and how that all works. There are emerging formal tools that are improving, like session types, that can describe not only syntax of data, but also protocol sequences and so on, and we should start making use of them. The last one, at least I find it very useful, to make the information flow the main design target that I care for. So I think about who knows what, who else would need to know, and then I need to design how the information gets from A to B. This gives me a pretty good insight into which messages shall be sent around at what times and by whom. So if you take a look at that and compare it, so this list, and I mean the titles were slightly different and so on, but we started also from a different focus, but the list reads very similar to the reactive principles. This is not a coincidence at all, because both the cloud native reactive principles and the local first principles here are derived from the desire to have something that stays responsive, that stays maximally useful at all times. So if we start from the same premise, we are likely to arrive at a very similar solution. Now, before I finish, I'd like to show you one example case of how we are doing this at Actix. Actix makes software tools for developers that make software for factories. So real factories where goods are made. In this case, I chose an example where you have two logistics vehicles with one robot mounted on each. And now they want to collaborate. They want to form a fleet, a logistics fleet that supplies machines with input materials, takes away output materials, puts them into storage or into the shipping bay so that it can be shipped to the customer. What we need to do here is we need to outfit each of these vehicles with a computing environment. So we need to put basically a CPU and memory and some storage on them. And then what we can do is we take this physical thing and make a digital twin for it. The digital twin is an established principle in mechanical engineering, in industrial digitalization, where you take the state of the physical robot, for example, and transform it into a data structure that represents this robot. Usually this digital twin lives in the cloud, so you can send it commands and then the robot will eventually move or pick some mission. And you can look in the cloud what the state is of the robot at any time. Now what we do, since we want to make this local, we do not create this twin in the cloud or in some computing center, but we create it on the local CPU and memory. Now we have this digital counterpart. Nothing spectacular has happened yet. But what if we allow communication? So we had autonomous parts, now we make them cooperate. What we do is we take the document that we have created here, the digital twin, the local twin on the right-hand side, and put it in the local computing environment on the left-hand side. This makes it seem to the programmer of the logic that writes the collaboration between these two, as if there is a local way for these two devices to talk to each other. This is the programming model that we offer, that you can do that. Now, since everything is designed according to these principles that I talked about earlier, and is meant to stay maximally useful under all conditions, this continues working even when the communication fails. What happens in that case is that the local twin of the right-hand side here on the left-hand side will get outdated. It will no longer know what the right-hand side robot is currently doing. but it still knows what it was up to while the communication was still working. So there is still useful communication that can happen even during those times. So in closing, I think this might actually be the way in which we can build an actual Internet of Things. Now, there is a web page that I wanted to show you about local first cooperation. The URL is this one, local first cooperation GitHub.io website. It's not yet polished, not yet much published, but if you want to get involved, you're very welcome to. If you have any critique whatsoever, let me know. And thanks for your attention.